Testen. Probando. 1, 2.
Hello, mister.
Hello. Permítame un momentito. Solo déjenme configurar esto otra vez. Este pinche mouse, yo no sé qué me cae mal. A ver. A ver. Alguien que me hable, diga algo. Hola.
Hola, mister.
Ahora sí. Ok, muchachos, primero que todo, antes de iniciar, enciéndame esas cámaras, por favor. Si Dios los bendiga, los guarde, los cuide. Lorna, David, Adrián, el resto, por favor. Gracias por encender sus cámaras. Primero que todo, antes de iniciar la clase, muchachos, déjenme decirles que ya la mesa está cumplida. Desde anoche hice el ajuste de los 5 puntos oro prometidos a la clase por la participación de los vídeos de las fiestas patrias. Solo que el sistema para que me emitiera esos 5 puntos oro, tuve que distribuirlo en 17 puntos. O sea, 17 puntos normales son equivalentes a 5 oro. Entonces, donde hubo una pequeña dificultad, vamos a decir, en aquellos estudiantes que habían sacado cerca de 100 o 100 en el examen, entonces tuve que distribuir los 17 puntos en las otras áreas, tareas, classwork, homework y cosas por el estilo, ¿verdad? Entonces, primero que todo, agradecerles de antemano su diligencia y su participación en dicha actividad. Bueno, eso es por un lado. Y por otro lado, muchachos, ustedes saben que yo sé que estamos a un mes, ¿verdad? Pero ya se acercan lo que son las actividades de las fiestas patrias. Fiestas patrias, perdón, las actividades navideñas es la cosa. Entonces ustedes saben que todos los años se preparan, no sé si son cantos, poesías, mensajes alusivos a la Navidad. Ok, gracias, hija. Gracias por avisarme. Entonces, no sé, necesitaría la colaboración de ustedes para que nosotros armemos un pequeño programa navideño que realmente se estaría entregando en este caso a Mr. de Computación, los videos recopilativos para poder, ¿cómo se llama? Participar en las fiestas navideñas. Podemos hacer algo muy similar con lo que hicimos en las fiestas patrias, solo que en esta ocasión sería con las festividades navideñas. No sé ustedes qué opinan. Hello. Hablen pues.
Quiere que hagamos actividades o propongamos actividades como propusimos en la fiesta patria, ¿verdad?
Algo así, podría, para hacerlo algo mucho más rápido, sencillo, y así pues yo me podría contactar con el mister de computación con tiempo, porque tenemos los maestros guías, tenemos como deadline hasta el 3 de diciembre para entregar esos vídeos. Entonces, por eso es que les estoy avisando desde ahorita. No tiene que hacer aquellos vídeos enormes, largos, ¿no? Sino que algo corto, o sea, algo como parecido con lo que hicimos en las fiestas patrias, pero alusivo a la Navidad. No sé, alguien puede decir, miren, nosotros en la casa comemos tamalitos de chanchito con pozole, otro puede decir, hacemos chocolate caliente, nosotros hacemos tal cosa. No sé si me doy a entender, ¿ok? Bueno, entonces en el transcurso del día, pues podemos ir discutiendo, voy a platicar con los otros profesores para más o menos tener una idea de qué actividades han hecho en los años anteriores para más o menos tratar de combinar una nueva, ¿ok? Bueno, entonces vamos a cambiar lo que es la cámara, permítanme, vamos a pin my video y vamos a arreglar esto que toda la vida me lo desconfiguran, perfecto. All right, I'm going to start solving more examples of the long division of polynomials, okay? So the instruction is the same, right? But this time we have three more examples, okay? The instruction we're talking about, we had to find the quotient remainder of the following functions. The first one, f of x equals ax4 plus 6x squared minus 3x plus 1 over 2x squared minus x plus 2. All right, we must find the quotient and remainder applying the long division. But remember, before to apply the long division, we have to make sure if the numerator and denominator are represented in decreasing canonical order. What does that mean? You have to take a look in the power of the variables. If you see in the numerator, the equation of the function, the numerator is a 4th-degree or 4th grade, right? Because it's the maximum power is 4. So starting for x4, and after that it's jumping to x squared. That's supposed to be x cubed. And after x squared, x and plus 1. For that reason, we can say the numerator it is not representing in a canonical order. What we have to do, at the moment we're going to divide the expression, we have to complete x cubed adding a 0. And by the other hand, in the denominator, 2x squared minus x plus 2, we can say, oh, okay, this is a canonical order. Well, let's going to proceed applying the long division, okay? So let's going to start with a denominator. 2x squared minus x plus 2 divided by the expression ax 4 power, and because there is no x cubed, I'm going to add 0 x cubed and complete the rest of the equation. Plus 6x squared minus 3x plus 1. Okay? And now we are fully prepared to obviously proceed. For example, one number multiplying by 2x squared gave us 8x 4 power. Simple. If you,
4x2.
that will be 4, right? Because 8 divided by 2 will be 4. 4 what? X squared, right? Remember, this 4x squared will multiply the 3 terms, okay? And remember, how do I got this 4x squared? Dividing the first term, this one, with the first term of this one, and we got the answer. And remember, at the moment I'm going to multiply these expressions, remember, the sign that I'm going to write inside this division will be the opposite. For example, you know, 4 times 2 will be positive 8. Okay, outside gave us positive, inside we'll write negative answer. Okay, so positive times negative is negative. Okay, this time will be positive. On the other hand, 4 times 2 is 8, positive 8. Okay, this is going to be negative 8. All right, and we can perfectly proceed to divide. I mean to subtract or adding. A minus 8 disappear. 4 plus 0 will be 4x cubed. 6 minus 8 will be negative 2x squared minus 3x plus 1. Understood until this part? Yes or no?
Yes.
Okay, then
So
don't
we
forget.
use we use the opposite sign
Inside the
inside.
operation. So how do I know how do I know when that long division will finish? Remember, what did I tell you yesterday? If the maximum power on the letter x in the remainder is less than the maximum power of the division, then the divisor, the long division finish or ends, okay? But in this case, we have x cubed, and x cubed is greater than x squared. For that reason, we must continue. Once again, because we have to matching this first term with this one, you can divide. 4 divided by 2 is 2, okay? You know, that will be positive 2. 2 what? 2x, because x cubed divided by x squared will be 2x, all right? And now, this 2x can be multiplying the 3 terms, and remember what you said. We're going to write the opposite side inside the long division. I mean, 2 times 2 is positive 4. That will be negative 4x cubed. Okay? Now, negative times positive is negative. This is going to be positive. Positive what? 2x squared. And finally, 2 times 2 is 4x positive. This line will be negative. So let's going to do it. 4 minus 4, cancel. 2 minus 2, cancel. Negative 3, negative 4, negative 7x plus 1. So we can perfectly check this is x and this is x squared, right? For that reason, what does that mean? What does that mean?
That is the
X,
remainder.
yeah, that will be the remainder. I'm going to change the remainder using another color just for remarkable, okay? So the answer will be negative 7x plus 1. Well, we have the solution set of the problem. Remember, find the quotient, QDX, and this is going to be the remainder, all right? And let me introduce another way to establish or represent the polynomial f dx. Okay. Eh, do you remember how to transform a fraction into a mixed number, right? The only thing that we have to do is divide, and after that, transforming the in mixed number. Okay. In this kind of polynomials, there's a one singular formula to transform the fraction in the, we can say between parentheses, um, how to say that, mixed number, but this is not the right thing that we have to do it. This form, this is when we're talking about algorithmic form. This algorithmic form, I'm going to use the letter f dx because it's the name of the function. Has the following, this formula will be given by the quotient QDX, positive, negative, because it's dependent the sign of what? The remainder divided by the divisor. This is the formula that we're talking about, the algorithmic form, or in simple merely words, how we can rewrite this long division expression, okay, into a mixed number, if you want to say that thing. So what we're going to do, simple, we can write f dx equals, instead to write q dx, the quotient, you know the quotient is 4x squared plus 2x. What will be the sign? Well, the remainder will be negative 7x plus 1, or if you wish, we can arrange like a 1 minus 7x, or negative 7x plus 1 is the same, okay? And this going to divide the divisor. And the divisor is 2x squared negative x plus 2. And if you see, this is the same polynomial written in algorithmic form, right? This could be when in math, in singular arithmetic expression, we're talking about the mixed number. This is going to say the mixed polynomial, mixed number polynomial, but the real name of this situation is the algorithmic form. Understood?
So we convert the answer into a polynomial, right? Into
Exactly.
a equation.
And this equation has a name, algorithmic form. Algorithmic form. Okay? And it's the mixed number of the equations in simple matter words. Okay? Now, we're going to solve the letter B. Let me separate this one. Bueno, hay que optimizar el espacio de la pizarra. Okay, let's going to check the second one. Remember, that denominator is a canonical order. Yes, because it's starting from x squared minus 2x plus 2, canonical order. But however, the numerator, it is not a canonical order because we're starting from x cubed, and after that, that's supposed to be x squared, okay? But there is no x squared. For that reason, we have to complete that equation using the using zeros. Okay, let's going to begin once again. We have the denominator x squared minus 2x plus 2, you know, divided by x cubed plus 0, x squared plus 6x plus 3. Okay, and now we have the canonical order. 3, 2, 1, 0. Disappear. Okay, and remember, we have to fulfill our matching, trying to matching the first term of this division. You know, we have x cubed, and this is x squared. Well, you know, we have to add is only the letter x, right? And remember that letter x will multiply the three terms, and we're going to write the opposite sign and obtain outside. For example, positive times positive is positive. This is going to be negative x cubed. Positive times negative is negative. Well, this time will be positive. Okay. Positive times positive is positive. This is going to be negative. Okay. Perfectly cancel these two terms. And we got 2x squared plus 4x plus 3. Okay. Now we must continue because the maximum power of this remainder is x squared, and this is x squared, so we can continue that situation. And to matching this expression, we can multiply by positive 2. I mean, going to add the number 2. And you know, positive is positive, and this is going to be a negative. Negative what? Negative value. 2x squared. Positive times negative is negative. This is going to be positive. Positive what? F 4x. And finally, positive times positive is positive. This is going to be negative. For that reason, we can cancel and we can perfectly write the remainder. The remainder will be 8x plus or negative 1. How do I know this is going to be the remainder? Because if you see, we have the letter x located over here, and x is less than x squared. For that reason, this we must identify this is going to be qdx, and this is going to be rdx. And if you want to write this answer the algorithmic form, just follow the same formula located over there. I mean, have the, well, this case will be gdx because the name of the function is gdx. gdx equals the quotient, I mean, x plus 2 plus the sign of the remainder, 8x minus 1 divided by that divisor, x squared minus 2x plus 2. And that's it. That's all that we have to do in the second one. Questions? ¿Estamos más claro? ¿Más claro? ¿Todo claro? ¿Todo azul?
Yes.
Okay, remember, the sign of the remainder could be positive, negative, depending the case, all right? Now let's going to begin with the third one. 2x fifth power minus 7x fourth power minus 13. Obviously, that expression, it won't be canonical order, right? Because starting from 5, 4, and jumping 3, 2, 1, and we have only negative 13 in the numerator. In the denominator, however, in the denominator, it is a canonical order. For that reason, we have to apply the long division in the term return. All right, I'm going to use the purple one once again. Okay, Let's going to start with the long division. We have 4x squared minus 6x plus 8. Okay, remember, divided by what? 2x fifth power minus 7x fourth power plus 0x cubed plus 0x squared plus 0x minus 13. And we have the canonical order of this long division, okay? Now we can proceed, obviously, to do it the same situation. You know, we have to imagine this first term with this one. 2 divided by 4 will be 1/2, right? So we can use the fraction 1/2 x cubed power. Why cube power? Because we have 2 units and we really need to reach 5, are missing 3. And remember, the sign that we want to use in this situation, that will be the opposite, right? For example, positive times positive is positive, inside will be a negative, meaning negative 2x of the fifth power. Another one, negative times positive is negative, okay? This time will be positive and will be a 3x at the fourth power. Why 3? Because 6 times 1/2 is 3. And finally, positive times positive is positive. This is going to be negative 4 or what? X cubed. That's why it's so important, the canonical order, because we can rewrite the variables in the right below the right position according for their powers and their bases. Okay, so we can cancel this one. Negative 7 plus 3 will be negative 4 x to the 4th power, negative 4x cubed plus 0 x squared plus 0x minus 13. Okay, we can continue, of course, because this is 4th power, this is 2nd power. We must continue simplify this expression. And the only thing that we have to do is adding negative x squared, because negative 4x 4th power divided by 4x 4 power divided by 4x squared will be negative x squared, right? We are matching. Now this negative x squared multiplying the 3 terms, and remember, we must use the opposite sign, okay?
Mister,
Uh-huh.
it doesn't matter if you put 1x, right? It's the same.
No, it's the same. Negative, but however, negative 1x squared, okay? Negative, because he only said positive x squared or positive 1x squared, that will be wrong. Remember, matching. Negative 4x squared, x 4 power, divided by this one will be negative x squared, all right? Okay? Now, only
Okay.
change we're going to do it is at the moment we're going to proceed to adding or subtracting this expression. And just like this one. Positive times negative is negative, okay, but this time will be positive. That's why. Negative times negative is positive. Obviously, it's positive, but next time we're going to write a negative answer, okay? And another one, positive times negative is negative. This time will be positive, okay? Now we can perfectly reduce. We can really cancel. Negative 4, negative 6, negative 10x cubed plus 8x squared plus 0x minus 13. Okay? We have to continue because we have x cubed. This is x squared, so we have to match it. How we can match it? Trying to divide. Negative 10 divided by 4 will be negative 5/2, right? Right? Will be negative 5/2. Simplify, because 10 4 simplify will be 5/2. We are not using decimals. And because we have x cubed, this is x squared, we only require the letter x. Okay. Now let's going to proceed with the same term, the same movement. I mean, negative 5 times 4, negative times positive is negative, but this time will be positive and will be 10x cubed. By the other hand, negative, negative is positive. Well, this time will be negative. Simple. 6 times 5 is 30. 30 divided by 2, 15. X squared. Okay? Continue. Positive times negative is negative. Okay, this is going to be positive. Positive what? 8 times 5 is 40. Divided by 2 will be 20. 20x. Okay? And let's going to simplify. We eliminate this one. And we have negative 15 plus 8 will be negative 7x squared, right? Plus 20x minus 13. Okay? And what we have to do? Well, simple, because we have x squared over here, and we have x squared over here, we have to continue one more try. We have to do it one more try, right? So we can match it. Divide negative 7 divided by 4, negative 7, 4. So negative 7, 4, and you don't need to require another letter x because both are the same. But be careful, remember, just like Gustavo said, always we're going to write the opposite sign inside the division. In the first one, negative times positive is negative, but this time will be positive. It will be 7x squared. Negative times negative is positive. This time will be negative. Give me a hand. 6 times 7, 4. 6 times 7, 4.
21 over 2.
21 over 2.
21 half.
21 half. Okay, thank you. 21 half x. And then on the other hand, positive times negative will be negative. Well, this time will be positive. Okay. What am I saying? Yeah. And 8 times 7, 4 will be 14, right? One I'm wrong.
Yes, mister.
14, right? Perfect. And now we are fully prepared to provide the remainder. So in the first one will be canceled. So give me a hand. 20 minus 21 half.
19 half.
19 half, right?
No. Yes.
Yeah, 19 half. Because could be 40 minus 20. So yeah, 19 half x. You're right. And 14 minus 13 will be positive 1. Well, I'm confused. I'm going to change the color because we're saying the orange one will be the remainder, and the green one the quotient. Okay, so shun, 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 shun. This is going to be remainder, and this is going to be the quotient. Okay, now let's going to rewrite the algorithmic form. Okay, what will be the algorithmic form? Remember, the algorithmic form will be given by, in this case, HDX equals. Remember, first of all, we're going to write the quotient. I mean, 1/2 x cubed minus x squared minus 5/2 x minus 7, 4. Positive, negative, design the remainder. In this case, positive 19/2 x plus 1 over the divisor. And the divisor will be 4x squared minus 6x plus 8. And this is going to be the solution set of this long division. ¿Preguntas, muchachos? ¿Está todo claro? ¿Todo azul?
No, yes.
¿Alguien más? ¿Alguna pregunta, jovenazos? ¿O todo está macanudo? ¿Entendido? ¿Servido?
Ni se puede usar decimales o
Mire,
recomiendo mejor usar fracciones.
mejor fracciones, porque la idea no es estar usando decimales, a no ser que le diera decimales, pero casi siempre se usa fracciones. Sí, Julio, no mire que levantó la mano. Esa era la misma pregunta. Bueno, entonces, miren muchachos, ¿qué aprendimos? Bueno, ustedes yo sé que ya saben sumar, restar y multiplicar polinomios. Ya el día de ayer aprendimos cómo utilizar los productos notables, lo que le llamamos en inglés special formulas. Y complementamos las operaciones básicas de los polinomios con lo que es la división polinómica, lo que le llamamos long division. Ya el día de mañana, si Dios lo permite, ya entramos con el plato fuerte, que sería la factorización. ¿Ok? Ahí en la factorización, muchachos, solo para introducirles, aunque ustedes puedan tener las fórmulas en la mano, les recomiendo, pero encarecidamente, que traten de memorizar esas formulitas como que si fuera la tabla del 1. ¿Por qué razón? Porque si usted no se memoriza las fórmulas de factorización, escuchen lo que les voy a decir, va a ser imposible que ustedes puedan factorizar. Van a tener elemento ahí y no van a saber qué hacer para factorizar. ¿Ok? ¿Y por qué es importante la factorización? Porque de aquí en adelante, cuando miremos expresiones, polinomios y un montón de situaciones, la factorización lo va a seguir usted para el resto de décimo, onceavo grado, en especial cuando estemos viendo cálculo, si Dios así lo permite, que estemos viendo los límites. Y factorización es algo que va a estar fijo en sus mentes y en sus corazones, tan fijo como que si yo lo mandara a la pulpería y que me fuera a conseguir Coca-Cola con semitas. Así es sencillo. Entonces, mañana que comencemos con este tema, obviamente voy a introducir las formulitas, cómo se usa, las técnicas de factorización, y créanme, traten de aprendérselas como que fueran la tabla del 1. Si ustedes se la logran aprender y saben utilizarlas, van a ser maestros en la factorización. Pero si no se las aprenden, puedo hacerles 500 ejercicios diarios y aún así el resultado será el mismo. Bueno, entonces vamos a dejar la clase hasta aquí por el día de hoy y los veo el día de mañana a la misma hora por el mismo canal, ¿verdad? Dios
Yo,
los bendiga,
mister.
los guarde, los cuide. Los veo mañana. Bye
Yo,
bye.
mister.
So long. Take care of yourself.